jump back, way back then. Yeah, you're gonna have to. Um, the definition for absolute value, in case you didn't know, it's the absolute value bars. Okay, anything that comes out of the absolute value bars is always positive because it's the distance from zero on a number line. Right? Back in your geometry days, when you took the square root of a number, you really didn't worry about the negative, right? Because geometry was always concerned about distance. So you only had when you did like radicals and when you found the length of line segments and whatnot, it was always a positive number, right? Even angles can be negative. Um, do you guys know why it's always positive? Suppose I'm at school here, okay, and let's see, at 4, I'm at school, and I want to go eat lunch at Beefaroo here. Okay? If I walk from the school, say I go 4 blocks and I end up at Beefaroo, it's a positive number, right? I walked 4 blocks. What you're thinking is, well, if you walk from Beefaroo back to school, would that be a negative distance? No, because you can't take back what you walk, right? What if your home was over here and you walk from your home to school? Is that a positive number? Yeah, 4 blocks to school. What if you're at school and you walk home? Your home's over here at -4. Did you walk -4 blocks? Why not? Your house is at -4. It goes back to you can't walk -blocks. What are they? Somebody going to go in your body and take away 4 blocks? Can't do it. Right? I like. That's why I like to think of the points on a number line here. I know there's no mathematical term for them. I just like to call them the location points. All right. It's just something I made up, and it really kind of helps when I'm explaining absolute value in algebra 2 because there's a difference between the location points and the distance, right? Distance is how many units you went, and then the location points is where you actually walk to. They're different. Now, here's the catch: the absolute value has to be distance. That equals the distance. That has to be positive. No matter where your house is or where the restaurant is or wherever you walk to, it has to be positive. You can't walk negative unless you're in some kind of time warp or wormhole, right? And actually, I think if you go faster than the speed of light, I think Einstein said you can actually go back in time. Or, yeah, I think he did. Something like that. I don't know. I'm not a physicist. Does that make sense? So, if you're finding location points, it can be negative, right? -4. But if you're finding the distance, it has to always be positive. Okay. So, The equation here, the absolute value of 2x minus 5 equals 9. We don't know whether you're talking about, positive 9, the location point, or negative 9, the location point. But we do know that the distance is 9 units, right? Does everybody understand the difference between the actual distance that you walk and where you're walking to? So there's two different concepts there. And we don't know if you're walking to positive 9 or if you're walking to negative 9. That's why we make, whenever you see an absolute value equation, you have to consider both scenarios. Okay? You're going 9 units, but you don't know if you're going to go 9 units to the left of 0, which would be negative 9, right? Or you could be going this location point that's to the right of 0, 9 units to the right of 0. That's why you have the two different equations you have to solve with every absolute value equation. Well, just solve for x. And again, what we're doing now is we're solving for those location points. We already know that it's 9 units distance. Now we're trying to figure out where those location points are. So I'm going to go ahead and add 5 to both sides. So I have 2x equals negative 9 plus 5 is negative 4. Then I'm going to divide by 2. So I get one of the location points to be x equals negative 4 divided by positive 2 is negative 2. Okay. So one of the location points is negative 2. Again, location points can be negative, but the actual distance has to be positive. Or, let's go ahead and solve this one. I'm going to add 5 to each side. So I get 2x equal 14. And then divide by 2. So my other location point where I'm going to end up 9 units is at x equals 7. Well, here's my answer. By the way, again, in Algebra 2, you can always check your answers, right? If I plug in negative 2 here, 2 times negative 2, negative 4, minus 5, negative 9, but we're taking the absolute value of negative 9. Does that equal positive 9? Yes, that works. 7. 7 times 2 is 14. 14 minus 5 is positive 9. Absolute value of positive 9 is 9. So that works. Just in case you want to check. All right, let's do some problems. Number 1. I have the absolute value equal 5. So the distance of x plus 3 equals 5 units. I'm going to go ahead and consider both the 5 and the negative 5. I always like to put my negative numbers first. Now, if you're used to the other way, because most of you did this in Algebra 1, if you want to put positive 5 here and negative 5 here, it doesn't matter. Or x plus 3 equals positive 5. And then solve each one of these. I'm going to subtract 3, subtract 3. I get x equals negative 8. Or subtract 3, subtract 3. X equals 2. So there's my location points. And the middle is going to be 5 units from 2 and 5 units from -8. Questions? All right, number 2. I'm going to take what's inside, consider the scenario 7t plus 3 is going to equal -4, or take what's inside, 7t plus 3 equals +4. Solve each one. Let's see, I'm going to subtract 3, gives me 7t. It's going to equal -7. And divide by 7. So t is going to equal -1, or subtract 3, 7t is going to equal 1, divide by 7, so I'm going to get a fraction here. So t is going to equal 1/7. There's my answer. All right, to solve for these, when we split up these absolute values to find the location points, this one has an issue. It's being multiplied to 2/3. Okay. Before you split these up, you have to get that absolute value term by itself, the bars by itself. This is actually one term. Think of that 2/3 as a coefficient. What's the easiest way to get rid of a fractional coefficient? Yep, multiply both sides by the reciprocal. Cancel the 1. I get my absolute value of 1 plus 2x equals, now think of that over 1, the 2's cancel, I get 3. Now I can split them up, right? Let's see, 1 plus 2x equals -3, or 1 plus 2x equals +3. Then solve each one separate. Okay, you're going to subtract 1, subtract 1. I get 2x equals -4. Divide by 2. Divide by 2. I get x equal -2. Or, bless you. Let's see, subtract 1, subtract 1. See, 2x equal 3 minus 1 is 2. Divide by 2. So x is going to equal 1. Okay, number four. Number four has those asterisks, so we know something's going to be going on here. Okay. Well, the first thing we have going on is that we have to get those absolute value bars by itself. So I'm going to add 5 to both sides. I'm sorry, subtract 5 to both sides. My fault. So I have the absolute value of 2 minus 4x equals 3 minus 5, negative 2. Bless you. You're welcome. All right. So are we ready to continue here? We ready? I'm just asking because, those asterisks are going to mean something. So after everything I do, I kind of look at it and see if there's anything wrong with it. Is there anything wrong with this one? Or are you guys just still on holiday mode? Yes. Huh? Go ahead, say it. I think you. Yeah, the two's already negative. Is this possible? What do we know about anything coming out of the absolute values? You're absolutely right. Okay. Anything coming out of here. Remember, when we're in absolute value bars, we're still talking distance. This is not location point. Can the distance be a negative number? No. No, it can't. There is no solution to this. Now, if you didn't realize it at this point and you continued on with the problem, well, let's go ahead and continue on. Just because we like to do things, we like to do a lot of work. Okay, so I'm going to take the 2x, or the 2, as if I didn't recognize that this is not possible. So I'm going to go ahead and do the problem. So 2 minus 4x equals negative negative 2, which is positive 2, or 2 minus 4x equals negative 2. Then I solve each one of them. Mm-hmm. So I'm going to subtract 2. I get negative 4x equals 0. Then I'm going to divide by negative 4. And I get x equals 0, which is okay because 0 is a number on the number line. Or, let's see, subtract 2. I get negative 4x equals negative 4. Divide by negative 4. And I get x equal 1. Okay, there's a couple of ways we can think about this. The first thing we can do is check it. Okay, so let's go ahead and plug in 0 for x. Does the absolute value of 2 minus 4 times 0 does that, or plus 5, does that equal 3? 2 minus 0 is 2. The absolute value of 2 plus 5, does that equal 3? No. Remember, anything that comes out of here is positive, so 2 plus 5 is 7. Does not. So we know that this one doesn't work. Let's check the other one. 1. Let's see. Does the absolute value of 2 minus 4 times 1 plus 5, does that equal 3? Well, 2 minus 4 is negative 2. The absolute value of negative 2 is 2. Does that equal 3? No. So if you went ahead and didn't realize this, went ahead and solved all this and did all this work, there's no way to tell that there's no solution to this, is there? Unless you really think about this. In fact, you could actually think about the original problem here. Remember, anything coming out of absolute value bars is going to be positive. And if I add 5 to it, can it ever equal 3? Can a positive number plus 5 equal 3? Ever? No. So right off the bat, I could have saved all this time if I would have recognized it. So be careful. Even if you do the first step, when you have those absolute value bars by itself, the distance could never be a negative number. I guarantee it, they're going to trick you up um, on the SATs on this, and probably the quiz. Any questions, guys? Are you done with me talking? Yeah, Justin.
What number 5 is it? We have to let them figure it out.
Actually, I scratched it out. What was it again?
5, absolute value bar, 2 minus x minus 3 equals 20.
There's just you're gonna have to get the absolute bars by themselves. So you're gonna have to add 3, and then you're gonna have to divide by 5. I have 5 times the absolute value bars of 2 minus x equal 15, and then divide by 5. So you have the absolute value bars of 2 minus x equal 3. Then you would separate and solve. Okay. Want me to keep going? Let's see, x equal 5, and then um, the 1, negative 1. Questions, comments, concerns? Guys, get all this? You seem really, really, really groggy.